So students, we were looking at the closed world assumption and the circumscription examples in the previous class, which is a type of minimalist reasoning. In the earlier classes, we looked at the default logic, wherein if you what do you mean by default logic? The most probable implication, you take it as your final assumption or the final reasoning. If I say birds typically fly, you write a rule that most of the birds are going to fly. So that is default reasoning and or default logic or non-monotonic type of reasoning. So default logic is an example of non-monotonic reasoning. Okay. And the next thing is minimalist reasoning, which I saw in the last class, and we had few assumptions that we are going to make. Based on the few assumptions, we come to a conclusion. In minimalist reasoning, you have minimum amount of information. Like I was telling you in the closed world assumption example that I told you, say I have the database of students. Okay, say I have the database of students with marks only for my subject AI. Okay, so if I'm having like this, then what do? What happens exactly, or what should I be doing? What is the assumption I should be making? So just by looking at few marks, I am going to conclude that this is what it is. I'll just randomly pick, say somebody is absent, I'll say that okay, this person is absent for the entire test. For all the tests, this person is absent because I don't have the information if the person has attended some other subject test or not. So this is a closed world assumption. Okay. But rather than doing this, if I am, able to do something like circumscription, where what happens, I'm more interested in the whole formula that is involved. Okay. Here also, the information that I have is only minimal. That means I have minimum amount of information, minimum database information from my in my database. I just have the marks of all my students. But the difference in circumscription is that I will operate on whole formulas, not on the individual predicate. If I just apply a formula, say find all the blank or empty spaces on the entire database, I'll pick all the absentees. Okay, and I'll say that all these students are absent for my test. Or if I want to find out all those students who have got more marks, more than 15 marks, okay, all those students who have got more than 15 marks, then that's also possible using this assumption. I'll just apply a formula in the Excel sheet in my database and I'll extract all that information. So this kind of there is an advantage in doing this because when you apply a formula, or you are more concerned about what to apply or what sort of formula or a methodology you're going to apply on a database, you will come to a better conclusion on it. But even here, whether it is closed world assumption or circumscription, the reasoning is done on minimalist data. So we assume here, if you look at the minimalist reasoning, okay, minimalist reasoning itself is all about having many fewer truer statements than the false ones. So we pick all the true statements and we make all our assumptions only based on the true statements. All right. Okay. So there are a few implementation issues when you consider all these minimalist reasoning. Let us go through one by one what it is. The first issue is this: how to derive exactly those non-monotonic conclusions that are relevant to solving the problem at hand, while not wasting time on those that are not necessary. What is the meaning of this? So you may have huge amount of information, or you will have minimum amount of truth statements or more of truth statements, out of which you have to come to a conclusion. Minimum amount of truth statements means typically all birds fly, or all birds typically fly. This is a minimalist information that you have. So how do you derive logical conclusion out of this? Or if you want to implement the statement in a logical form, how do you do it? So when you have minimum amount of information without, spending too much time on the negative aspect of it, that is to find out whether some birds are not flying or not, are there any birds that are flightless, these kind of things, you will have to somehow come to a conclusion, right, if the information is less. So implementation wise, this is a big hurdle that you'll face. Next thing is to update our knowledge incrementally. Suppose I give one more statement saying that Tweety is a bird which does not fly. That means to say that though all typical birds fly, typically all the birds fly, there can be a bird called Tweety which can be a penguin, say, okay, which is not flying. Okay, so updating the knowledge in your database can change the entire nature of your problem. So this is also one issue which you will face when you will implement it. So in general, we can say that all these theories, if you want to make a computational model, it is not very effective. Okay, so what can we do in order to represent all this knowledge? Okay, first of all, we should have a system which figures out the truth in the statements. Okay, to find out how true is the statement, or how true is the justification that we are going to give for a particular knowledge representation. So how do we do that? We know the depth first search implementation, so that is mainly used in most of the cases. Okay, and there is something called as a truth maintenance system. Okay, so what exactly is this truth maintenance system? You can read over here. It's also called as reason maintenance system, and mainly for all the problem solving in along with earlier I was telling you something called as inference engines. Okay, where if a particular rule is given for a problem, it'll infer and give you the outcome. You just have to give the inputs, it is going to give you some uh, reasonable output. So a truth maintenance system is something like this, where you solve some problem by figuring out what is the amount of truth that is present in the statements. So if you see, there are all these kind of methods. The Before that, we'll just look at the goals. You can see the goals are written here. It provides justification for conclusions, recognize inconsistency, remember the derivations computed previously, and support the dependency driven backtracking. What is the meaning of all these things? Provide justification for conclusions means there are a set of truth statements that you have, and you justify that it is true. Okay, and by how much percent? Say I say all birds typically fly, then you need to provide justification for that. Does all the bird really fly, or do all the birds really fly? And what is a conclusion, proper conclusion that you can say? You can say that there are also some flightless birds. That is a proper conclusion. Okay, so how do you recognize the inconsistencies? You cannot always say that all birds fly. There could be a flightless bird. So finding out that is called as recognizing the inconsistencies in the statement in the truth management system. Sorry, truth maintenance system. This truth maintenance system has to figure out this also. And apart from that, you also need to find out what is the default reasoning. Or default reasoning means majority of the statement, or the majority rule. All birds fly, that is a majority rule. Okay, so that is a default reasoning. That means that majority of it is going to fly. So that is the default reasoning. What is the default reasoning in a statement? Remember derivations computed previously. So this you cannot analyze using that example. Earlier, if you have, say, I have given you some 10 statements, 10 to 15 statements, and I analyze the first 5 statements initially. So there is some conclusion that I draw out of that. So whatever you have drawn from the previous derivations or computed previous computations, you need to keep that intact when you do the further uh, computations also. Apart from that, how do you support the dependencies between these statements, and how do you backtrack? Say you have backtracking is similar to the logic of abduction, where if I say the grass is wet, you infer that it would have rained. Okay, so can you go back from the outcome? Can you go back and decide upon what is the inference? Okay, all right, and now one by one we'll just look at the types of this truth maintenance systems. One is justification based, one more is assumption based, and one more is logical based truth maintenance systems. Okay, so generally speaking, if we really have to make a computationally efficient model, right, truth maintenance system, you should conclude the probabilities of each and every truth statements that are made. So that is the best way to build a model. So building the model, will come to that later. It comes in the part of statistical reasoning. But then we need to look at what is your truth maintenance justification based truth maintenance system, assumption based, and logical based. So in case of justification based truth maintenance system, you can see in the second slide here, you can have a graph implementation. So you have an evidence for something being true, a statement, and you can also have an evidence that must be false, okay, which are not coming in that. So based on this, you come to a proper conclusion. Okay, so you have both the assumptions. One is the positive statement, and you also have the negative statement, and you kind of implement this in the form of a graph, and you say that this is the outcome of the analysis that we have done. So suppose, as and when a new piece of information is added, you can consider the birds flying example. All birds typically fly. I will also add that some birds like Tweety, some birds like penguins don't fly. So that is a new statement. When I am adding it, we need to analyze the new piece of information that we have, and if it is going to change. Suppose the positive statement is birds fly, okay, and the negative statement is some birds like penguins don't fly. So if I add this statement to, okay, it is a justification that some birds really don't fly, and it contradicts the first statement. So when I'm adding that to this, okay, it changes the total inference or the conclusion that we are going to get. So we should have a justification for each of the evidences that are given over here. And how does this work? How does your justification based method work? It works on 3 operations. First is through inspection. So in case of inspection, the entire true propositions you inspect, whether it is correct or not, you try to analyze. Secondly, if new statements are added, okay, you kind of modify the graph that is given to you. Okay, you try to modify and find out internally. It is, if you analyze it, it is about probability calculation. How many birds can be flightless, how many birds can fly. Okay, that way you can think. You can take any example for understanding here, because earlier I have explained to you regarding this bird example. I'm taking the same thing. Next thing you would do is update. How do you update? Just think for a moment. Whatever modifications you have done, okay, at every node, suppose you are implementing using a depth first search algorithm, you will have to update at every node the different kind of value. Suppose you're assigning some values to all of this, say probability values or whatever, based on the model. You need to update those values so that whatever modifications you have made throughout the search tree, it is propagated. So it's very important to do inspection, that is, you're searching whether the entire true information is actually true. You will check whether you have to do some modification, okay, and then you update. So that is why it is called justification based truth maintenance system, where at every step you're going to do some or the other operation and you're updating each and every node. Okay. So when it comes to the second type, assumption based, here the only difference that is there from your justification is it is all based on assumptions. You do not think of justifying each and every node. So assumption based truth management system or maintenance system is like that. It does not actually bother about the actual meaning of the sentences. Okay, if you say typically birds fly, okay, it means that all the birds fly. That is the assumption you make. So based on that assumption, you whatever further things are going to be added, you just go with the majority assumption. That means your default reasoning kind of an analogy is applied to every statement that is there. You don't analyze the relationship between each of the node, and you just assume and you go forward. That is assumption based truth maintenance system. Logical based truth maintenance system, the third one, is similar to your justification. There is justification involved. The only difference is that it reasons with a few set of assumptions that you have. Okay, so you try to draw some logical conclusions out of that. And if I say a particular statement, say it is P, what is negation of P? That means if I say all birds fly, negation of that is what? All birds don't fly, or some birds fly. What is that? What is the actual logic that is involved? The true logic that is involved is tried to be found out in case of logical based truth maintenance system. That is the only difference between that and justification based method. Okay. Only thing is, in case of C, you can see here it's mentioned in your justification based methods, nodes in the network are treated as atoms. Atoms means simple nodes like these, okay, which assumes the relationship among them except the ones that are explicitly stated in the justification. In justification, you explicitly state if there is an assumption, some birds don't fly, then you explicitly state it. Okay, that is the only difference between justification and logic based. In logic based, you try to establish the proper logic between the ones. See, this difference between all of this is very subtle. I hope you understand. Go through the slides once again. If you're having any doubts, I've shared it in the group. And the next thing that we need to look into is the statistical reasoning. I was telling you in the earlier classes also that the statistics or the probability of a particular thing is very important for you. Probability of each of the truth statements. So if I give you a set of truth statements, what is the probability that something is high? Okay, all that is understood by statistical reasoning. So here it is rather like finding out how random is the data. Suppose you're playing a game of cards, okay, or you're rolling a dice. Okay, I hope all these examples are familiar to you. These are all probability, the way to measure or the problems which define what to say your probability values, right? How probability plays an important role you can understand in all these examples, isn't it? So here we consider something called as the Bayes theorem, probability theorem, or the Bayes theorem. You can see the Bayes probability formula over here. P of A bar B is equal to P of B bar A into P of A into P of B. What is P of A and P of B? P of B is the probability of event B. Probability of event A is P of A. A by B is the probability of event A occurring given that event B has occurred. B by A means probability of event B occurring given that A has occurred. I hope you understand this. It's very simple. So we will see an example based on this. You can see here. Suppose in a school with 100 students, we'll understand the statistical reasoning based on the probability values. You come to a conclusion. So this is a very logical kind of an approach, logical truth maintenance system, if you can actually look at it, where you use the statistics of the data and you measure the probability, and based on the probability values you come to some proper conclusions with respect to the data. Okay, so how do we do it? For each of that, for each of the truth statements that you will have some probability values that are given to you, based on which you will come to a conclusion. So these will solve as some problems, not exactly problems. You would have studied the probability theory, something similar to that. We will see how it is done. So how do you find the probability of this? Suppose in a school there are 100 students, and out of that 55 students study maths. Okay, so studying maths, you consider it as an event A. 25 study biology, which is event B, and 20 study both. That means there's 20 of them study both maths and biology. Okay, so P of A by B means probability that a student studies math given that he studies biology. P of A by B. B by A is what? Event B is studying biology, event A is studying maths. So A by B means the student has already studied biology. That means he's already studying biology, and you want to find the probability that he will study maths. B by A means the student you know is already studying maths. You want to find the probability that the student studies biology. That is P of B by A. These two values, this is what I'm telling. Okay. So now, how do you find the probability that some particular value A by B and B by A, you want to find out what is the probability of each of this? Okay, out of 100 students, if a person is studying, okay, 100 students, 55 are studying maths. So what is the probability of P of A? 55 by 100, right? Studying maths, P of A is 55 by 100. So that is 0.55. Okay. What is P of B? P of B is what? How many students are studying biology? So P of B is 25 by 100. That is 0.25. Okay. All right. So you know P of B, P of A, both you know. And all you have to find is P of A by B, B by A. So you know the formulas for those. You can see here. P of A by B is P of A intersection B by P of B. And P of B by A intersection B by P of A. Use these formulas and find out the value of P of A by B and B by A. A intersection B means 20 of them study both. Right? So it is A by B value is how much? P of A by B. How do I do it? What is the value? P of A intersection B by P of B. A intersection B means 220 study both. So 20 out of 100 is the probability P of A intersection B. Whole thing divided by P of B. You already know how many of them are studying this one, the value biology, 0.55, sorry, 0.25. Okay, So put this value, this will give you your P of A intersection B by P of B, that is P of A by B. Is it okay? Very simple. Similarly, P of B by A, you will get by P of A intersection B the same thing, 20 by 100, that is 0.20. Okay. Divided by P of A. P of A is how much? 0.55. Okay. You will get the same answer. 0.36 you will get for this. For the previous one, you will get 0.88. So this is how you write it. The other formula is also given here. You can just look at it. So this is Bayes' theorem. These probability values, why are we calculating? It will help us to ascertain what is the actual probability that randomly, if you pick a student, the student is going to study maths. The student is going to study both biology and math. Okay, the combined probability A intersection B. Or what is the probability the student will study only math or only biology and not both. You will do 1 minus the answer for each of these. Okay, right? Because maximum probability value is 1. Hope you have understood. Okay. I think from this I'll do it in the next class, and I want all of you to write down the answers in the question bank, module 3, whichever possible, in your notes in today's class.